Okay, so we're going to look at these first two topics here that we have left for the week. So first, remember that the Pythagorean Theorem is a squared plus b squared is c squared. And remember that that c is always the hypotenuse. It doesn't matter whether it's a and b or b and a or whatever. So looking at this first problem, we want the cosine. We have adjacent, but we need hypotenuse. So we're going to have to set up the Pythagorean theorem to find that hypotenuse. So 16 plus 49 is c squared. You can also label that x squared. Doesn't matter at all. I kind of go back and forth. And then solving gives us the square root of 65. So then going back, the cosine of theta is 4 over the square root of 65. Notice the instructions up there say to give exact values, so we don't want to do anything other than that. We also don't need to rationalize that, because if we did, it would say simplest rational form or whatever. Looking at the next one for the tangent, we have adjacent, but we need the opposite. So again, we'll set up the Pythagorean theorem. Notice this time I used x. It really doesn't matter. It's for your own work there, right? So we get that opposite is 4. So the tangent would be 4/3. So I don't feel like we need to do that next one, but let's look at the next row here. Hopefully you are following along with your notes. So for this one, they want cotangent, secant, and cosine. So eventually we're going to have to find that missing side anyway. So we might as well go ahead and find it, right? So we'll label it, set up the Pythagorean theorem, and we end up with x is the square root of 15. And then using that information along with our triangle, we can find all of the pieces. Okay, I don't think we need to do the next one either, right? This ought to be pretty good. I thought, okay, we'll do the next one in the next video.